So we have to find out a Routh stability criteria for this kind of numerical, and it is based on the difficulty number 2. Okay, so first we will go for the as usual solution. Okay, the first is what is the step? The standard characteristic equation is a0 s to the power n plus a1 s to the power n minus 1 plus a2 s to the power n minus 2. Likewise, we have to go till the a2 an equal to 0. This is equation number 1, this is equation number 2. Now compare the values. So we get a0, a1, a2, a3, a4, a5 and the a6. Okay. A0 is 1, a1 2, a2 8, a3 12, a4 20, a5 16 and a6 also a 16. Okay, the next step is what? The next step is we have to go for the Routh's array, starting with the highest order, that is s to the power 6, s to the power 5 till the s to the power 0. Okay, and the first is of even terms, second is of odd terms, which means exactly opposite odd and even. Okay, so this is 1 2 8 12 20 16 16. 1 2 2 1 2 8 12 20 16 and the 16, and this will be 0. We go for the s to the power 4. Okay, next row is s to the power 4, 2 into 1, sorry 2 into 8 minus 12 into 1 upon 2 equal to 2. Similarly, next 2 into 20 minus 16 into 1 16 upon 2. Answer is 12. Next 2 into 16 minus 0 into 1 is 0 upon 2. How much? 16. Okay, this row is completed. So we will go for the next, that is s to the power cube. For this we will consider s to the power 4 and s to the power 5. So 2 into 12 minus 12 into 2 upon is 2. What is the answer? It is 2 into 12 minus 2 into 12 is 0. Clear? Similarly, 2 into 16 minus 16 into 2 upon 2, again a 0. Next, here the term is 0. Okay, red. Next is 2 into 0. 0 into 2 upon 0 is again a 0. Okay, that means here we get s to the power cube. Okay, s to the power cube row is all 0 terms. We have all the 0 terms. So this is a difficulty number. So for the simplification, I'm just removing this. This is 0, this is 0, this is 0, and this is 0. Okay, clear? The next step is that when we get all the terms as 0, this is a difficulty number 2. When we get all the terms as 0, then for the resolving this, we will form an auxiliary equation. We have to form an auxiliary equation. Auxiliary equation can be formed by the exactly above coefficients of all the rows 0. When we have s to the power cube terms, s to the power cube row is 0, then we can form an auxiliary equation using the s to the power 4 row. Okay, how? See, next is coefficients are 2 plus 12 plus 16. Okay, now this is 2 s to the power 4. Okay, starting with the s to the power 4. Next is 12 s to the power square. Why s to the power square, not s to the power cube? मैंने बताया था आपको. When we go for this, okay, see, this is 2 s to the power 5 and this is 12 s to the power cube. हर रो में एक एक कोफिशिएंट जो पावर है वो कम होते जाता है. The order is -1. Okay, so here it is s to the power 12 plus 16. S to the power 2 minus 1 is how much? 16 constant equal to 0. Now we have after forming an auxiliary equation, we have to differentiate the auxiliary equation with respect to s. So d a raised to a of s upon s equal to how much it will be? The equation will be 8s cube plus 24s, and this is a constant, so it will be 0. Okay, now we will using these are the coefficients. Okay, so we will using this coefficients as in s to the power cube row and keep solving the Routh's array as a normal sequence. Okay, so we are replacing these values, s to the power cube values, here. These are the 8, 24, 0, 0. Okay, so we are keep solving it out array. S to the power 2, s to the power, for the s to the power 2, consider s to the power 4 and s to the power cube. So 8 into 12 minus 24 into 2 upon 8. Okay, next 8 into 16 minus 0 into 2, 0 upon 8 equal to 16. So the answer of this is 6. Next we go for the s to the power 1. S to the power 1, for the s to the power 1, we have to consider s to the power cube and s to the power 2. So 6 into 24 minus 16 into, wait, 6 into 26, 16 into 8 upon the 6. This is one. And next 6 into 0, and then 16 into 8. Answer, this will be 0. Yes, the answer is 8 by 3. This is s to the power 1 row. Next, for the s to the power 0, consider s to the power 1 and s to the power 2. 8 by 3 into 16 minus 0 upon 8 by 3. So it will be 16. Okay. And the one more method to check whether the Routh's array is correct or not. So always the s to the power 0 term will be the last term, the constant term of your characteristic equation. C. This 16 and this 16. It should be the same. Okay. So here we're done with the Routh's array. So the Routh stability, as per this Routh's array, we can say the first column, in the first column there is no sign change. Okay, there is no sign, that means the system is stable. But it is a which type of stable system? Critically marginally stable or normally absolutely unstable stable system? How it will be defined? Here we used a auxiliary equation. When we use an auxiliary equation, always there is a critical marginally stable system. Okay, we will go for this. To find out whether it is a critically marginally stable or not, for that we have to consider an auxiliary equation. Okay, auxiliary equation we formed using the s to the power 4 earlier. So s to the power 4 plus 12 s to the power 2 plus 16 equal to 0. Now we have to find out the roots of this. Okay, speedily tell me the roots. So it will be s to the power 4 plus 6 s square plus 8 equal to 0. Okay, for this s to the s plus, so for this it will be s square s to the power 4 plus 2s square plus 4s square plus 8 equal to 0. So it will be s square plus, sorry, it will be s square plus 2 equal to 0, or s square plus 4 equal to 0. So here we get two roots, s equal to plus minus root 2 and s1 and 2, and the second one is s2 comma 3 equal to plus minus under root of 4. Okay, for this tell me the root 2 value and the root 4. Using this value we will draw a graph. Okay, this is j omega axis sigma. So for this roots we have to draw a graph. Okay, j omega axis and the sigma axis. Okay, both are the on the imaginary terms. Okay, so plus first is 1 point j 1.414, and this will be plus 2 again minus j 1.414, and this will be minus j2. Clear? So since, what is the condition for critically marginally stable? Roots should be non-repeated. Since the roots of characteristic equation lie on the j omega axis are non-repeated, that's why the system is critically marginally stable. What is marginally stable system? Now, this is the one part of system. It is a critically marginally stable system. Now, these are the only four roots. Okay, the given order is s to the power 6, means the total roots should be 6. So the remaining roots lie on the left half of S plane will be how much? Total are 6 minus roots on imaginary axis, that is 6 minus 4 equal to 2. So the total 2 roots are lie on the left half of the S plane. Okay, this is a discussion of roots. How many roots are lie on the imaginary axis and how many roots are lie on the left half of S plane. Clear?